All right, so here are the notes for 2.5. We're solving all log equations, okay? This is putting together what you learned in 2.2, 2.3, and 2.4, okay? You're going to, on your assignment, you're going to be given a mixture of all those different types of problems, and you're going to have to figure out which one, what method you need to use to solve it, okay? But we're not adding anything new. You're using all the methods that we've learned in 2.2, 2.3, and 2.4. Okay, so it tells you there are 3 different types of log equations. A, it tells you all log terms. Okay, so when it gives you the example, you can tell that there's logs on both sides of the equal sign. It's giving you everything in log form. Okay, so this is what we learned in 2.4. Okay, this is where you have to condense your logs on both sides so that you can get it in the form of our property, log base b of m equals log base b of n. Okay. Then once you get it in that form, you can set m and n equal to each other. So m equals n and then solve for x. Okay, so I put out here notes for 2.4 on that one. Then on B, this is no log terms. This is when it's given to you in an exponential form and there is no log in the original problem. Okay, it tells you what to do. You need to isolate your exponent, your term with your exponent, okay? And then you're going to take the log of both sides. Right? And then you move your exponent in front of your log and you solve. This is what we did in 2.5. Okay, so look back at your notes for 2.5 on these examples for that. Now then C is our combination of terms. This is when you're given log on one side and not on the other. This is your combination, okay, with and without logs. So what you need to do there is you're going to condense your log, any of your logs that you can, and you're going to rewrite it in exponential form and solve. Okay, so this was the notes from 2.2. This is when you're going to use the equation log base b of n is equal to k. Okay, and so you would get it in this form, and you're going to rewrite it in exponential form, which is b to the k is equal to n. Okay. Now I'm going to do an example of each one of these. So solve each equation for x. So let's figure out, first you have to look at this and figure out, is it A, B, or C? So you have logs over here on the left, but you don't on the right. So this is going to be our combination. It's going to look closest to this example. So I'm just going to put out here, this is equal to C, okay? So you can look back at it. So now what do we need to do? You can divide both sides by 2. And you would get log sorry, thought I heard something. Okay, you got log base 2 of 5x, because this plus sign means you multiply the 5 times the x is equal to 4. Alright, so now using this formula, our b is 2. We're going to rewrite it in exponential form. So our b is 2. Our k is 4, and our n is 5x. So we're using that formula down here. So 2 to the 4th is going to give you 16 is equal to 5x. Divide both sides by 5, and you get x is equal to, oops, my paper's moving while I'm trying to write, 16/5. That's your answer. You can leave it in fraction form. Okay, so that was option C. So now let's do another example. Let's look at example 2. All right, so this, which one is this, A, B, or C? Is it all logs, no logs, or a combination? Okay, there are no logarithms in this. There's no log listed anywhere in this problem. Okay, so that's going to be, I think that was B. So let's put B. So now what do we need to do? You need to get your exponent, your term with your exponent, you need to isolate it. So subtract your 5 on both sides. You're going to get 12 is equal to 3 times 5 to the x. Alright, so now you can't multiply the 3 and the 5. Okay, this has an exponent of x, so you can't multiply it by the 3. So you need to divide by 3 on both sides, and you get 5 to the x power equals 4. Now then we have this term with the exponent isolated by itself, right? So now we can take the log of both sides. So your exponent moves in front. That was one of the laws we learned about logs. And now you can divide both sides by log 5. So now those cancel out and you get x is equal to, you're going to put log 4 divided by log 5 in your calculator. And you're going to get 0.861. And that's it. All right, number 3. This is going to be an example of A. This is all logs, okay? You have logs in each thing given, both sides of the equal sign. So now we're going to condense this side. So this is going to be, you're going to have log, and you have 2 to the 3rd power, if we were going to condense that, times x, okay? Because this plus sign means we multiply the 2 and the x, but this 3 means this is the exponent on the 2. So equals log 24. So now 2 to the 3rd power is 8, so you're going to get log 8x equals log 24. Now once you have log on both sides, you've condensed both sides, you can set this is 8x equal to 24. These are equal to each other. So now divide by 8 on both sides, and you get x is equal to 3. So that's it. All right, I'll go ahead and do number 4. It's a little bit longer. It's the same. It's option A because it's all logs. So we're going to condense both sides and so that we have log base b of x equals log base b of x on both sides. Okay, so this one you got a plus sign. That means we're going to multiply our 3 times our x. So log base 2 of 3x equals. Now on this side I'm going to leave my 2 for right now. I'm not going to do anything with it. I'm going to condense what's in my parentheses first. Okay, so you're going to get log base 2, and you're going to have 12 on the top because you have 12 times. This means you're multiplying the 12 times the 3 because of the plus sign in between them. Okay, but then on your bottom, because you have a subtraction, that means divide by 4. Okay, so now we get log base 2 of 3x equals, you're going to get 2. And you're going to get the log of base 2 of 12 times 3 is 36, divided by 4 is 9. So now this in front of the parentheses, I can move it to my exponent. Okay, so log, once I've condensed it, now I can move it. So log base 2 of 9 squared. Now I have log base 2 and log base 2, which is what I'm trying to get down to. I want to condense it on both sides so that I can get log and log. So now I can set 3x equal to 9x squared. 9 squared. So you get 3x is equal to 81. Divide both sides by 3. And you get x is equal to 27. Okay? All right.